Let us now get into the geometry and deriving the equation of correct steering mechanism. It actually does not matter whether your vehicle is taking a left or a right turn. In this figure, P, Q, R, S is the chassis of the vehicle. S and R are the points on the rear side of the vehicle. P and Q is the front side. And in this particular diagram, it is assumed that the vehicle is taking a right turn. Let's get used to the terminologies first. The distance between the two wheels, A, shown in the diagram, is called as the width of the track. Similarly, the distance between the center of the rear wheel and the front wheel is denoted by the wheel base, which is L. Also, the actual width of the chassis is defined in this figure as W. Notice that width W of the chassis, A, the track width of the car, and L, the length of the chassis or the wheelbase, these are all constants. These are all fixed. Now, if while taking a turn, we want the vehicle to take a perfect right turn in this case, which I would denote it this way. For the right turn, notice that the inner stub axle passing through Q and therefore the inner wheel will turn more at an angle theta with respect to the front axle PQ. At the same time, the outer wheel, which is P, connected by the stub axle passing through this wheel center, will rotate, but the angle of rotation phi will be slightly smaller than angle of rotation theta. Now, if you extend the lines passing through the two wheels of the center, they will both intersect at this point, which we call it as instantaneous center of rotation I. Also note that the instantaneous center lies on the line passing through the rear axis as seen previously. We are interested in getting a very simple relation between at what angle did the inner wheel turn and at what angle did the outer wheel turn. Now, consider this right angle triangle ITQ. So, in the triangle QTI, which is out here, we have an angle theta. If I consider tan of that angle theta, which is simply opposite side upon the adjacent side, we will get a TI divided by QT. As far as the equation is concerned, it is actually easier if we rewrite this in a cot ratio rather than in the tan ratio. So therefore, the same tan theta, reciprocal of it, would look like QT divided by TI. Now, similarly, there's a bigger right angle triangle PTI, which involves the outer wheel. So, in the triangle PTI, let's keep this separately. In the triangle PTI, again the same thing. If I consider tan of the angle phi here, it would be opposite side TI divided by the adjacent side PT. Same reasoning, if I consider the reciprocal of this, the cot phi would look PT divided by TI. Now, this is the geometry of your chassis or of the vehicle. Now, simply, randomly, consider the difference of cot phi and cot theta. Right now, you may not understand the reason why we have taken the difference, but if I just subtract the left hand side from the right hand side, we will have to subtract PT upon TI, right hand side of cot phi, minus QT upon TI, which is the right hand side of cot theta. Now, the LCM of both these would be Ti, and you would simply get Pt minus Qt. Now, from the diagram, Pt minus Qt would leave you with only the chassis width W, that we can call it as PQ. The denominator Ti, let us keep it as it is. So finally we get a ratio. Notice now that the chassis width PQ is fixed because the chassis is welded. So the numerator would be replaced by the chassis width W. Now the denominator Ti, which we have made it as an extension and a construction line here, would be exactly the same, if you get it here, as either QR or the distance PS, which happens to be the distance between the center to center when the vehicle is going straight. Now, this longitudinal distance is actually called as the wheelbase, and the wheelbase of it is L. Points to be noticed here is the width of the chassis and the wheelbase of a vehicle is all constant, and therefore we get a very nice relation between the angle turned by the outer wheel and the angle turned by the inner wheel, the ratio being cot phi minus cot theta would be given by W upon L. Notice here that the right hand side of this equation is a constant, and therefore the difference between the two is a non-zero number. This is very simple mathematics, and because the right hand side is non-zero, therefore anybody can prove that these two are not equal to each other. This particular equation is called as the fundamental equation of correct steering. So sometimes the word used is law of steering, or sometimes the word used is correct steering also. Now, if you make a mechanism for steering of a vehicle, and if that mechanism, whatever you make, satisfies this particular equation, we can call that mechanism as a steering mechanism. This is where we would like to go into part 2 and discuss two different types of steering gear mechanisms. Thank you.